In this video, we are going to continue our notes on lesson 3.6 as we look at example 3. Again, we will be looking at the area between two curves here. We can see in example 3, it says find the area between bounded by the graphs of f of x equals x squared minus 1 and a negative 1/2 x minus 3. And x equals negative 1 and x equals, it's not there. Let's go with 1. So if we look at this, if we want to find the area, actually, let's go with 2, since we can make up any number we want. Let's make it interesting. And we'll go between a negative 1 and 2. So if x equals negative 1 and x equals 2, those are the lines that we'd see here. There's negative 1 and here's 2. So there we go. We want to find this area here. I'm going to ask you guys to set it up, pause the video, and then we'll check and make sure we have it set it up correctly. So pause the video, let's give it a go. So we know to find the area between the two curves, we subtract the values and we integrate the subtracted values of those two curves. So in this case, we wanted to put f of x first because that is our parabola and it has higher y values. And we put g of x second, which is our line, and has lower y values. So your integral should look like the integral from negative 1 to 2 of the x squared minus 1 minus the 1/2 x minus 3. We're going to clean this up before we integrate it. And my x squared can remain first. And then I'm going to write it in descending order. So the negative 1/2 x is being subtracted, so it will become a positive 1/2 x. And then we have a minus 1 minus a negative 3. So that's really a negative 1 plus 3, which will give us 2. So this is actually the function we want to integrate. I'm going to ask you guys to go ahead and give that a go, show your work, make sure you have these steps clarified, substitute in the values, and let's see what you get. Pause the video and we'll go through it in a moment. All right, so we have it set up. And when we integrate x squared plus 1/2 x plus 2, we're going to get x cubed over 3. The 1/2 will remain out front here. And as we elevate or integrate x, we're going to get x squared over 2. So that comes here. As we integrate 2, we're going to get the 2x. And we're integrating this, as we recall, from negative 1 to 2. So our bounds get written here. This simplifies to x cubed over 3, x squared over 4, plus 2x with those same bounds. Substituting in 2 here, we can simplify it and get 23 over 3. Substituting the negative 1 in, we simplify it and get a negative 25 over 12, but we are subtracting a negative value. So we wind up adding those two, and getting a common denominator will give us 117 over 12 units squared, or 9.75 units squared. We do want you to be able to integrate these by hand. You don't have to use fractions, you can use decimals, but you have to be very careful with decimals because if you round too much at the end, your answer won't be very accurate. Let's try our next one. Okay, so we want to find the area bounded by 6 minus x squared, and g of x function is x. So notice how we didn't say the bounds of integration like we did in the previous two questions. So here, in order to know where to integrate from, we have to know where the functions intersect. So it's always a good idea to graph the functions. We could also solve this and find these bounds of integration at 2 and negative 3. We could set them equal. So if you did it algebraically, you'd say, where does 6 minus x squared intersect with x? So where are they equal? To solve this, you would move everything to one side. I'm going to make my x squared positive, so I'm going to move it to the right. And then you can factor this to x plus 3 and x minus 2. Then using our zero product rule, we'd say if this product, or if this factor times that factor equals 0, either this x plus 3 must equal 0, or this x minus 2 must equal 0. Solving, we get x equals a negative 3 and x equals 2. And those, voila, are our bounds of integration here. When x is a -3 and x is 2. So we're going to find the area in here. I'm going to ask you guys to go ahead and set up that integral, and we'll check it together. So pause the video, set up the integral, and then we'll see if we have it right. So for this one, we'd want to integrate from a -3 to 2. We'd put the f of x function first because we have our y values that are higher with our parabola, which is 6 minus x squared. And then from that, we'd subtract x, which is the line that falls below the parabola. Go ahead and integrate that by hand. You can check it on your calculator, and you can check it back with us in a few minutes. Go ahead, pause the video, and then we'll look at this together. So in this problem, we wind up integrating this function and getting 6x minus an x squared over 3, and then minus x cubed over 3, then minus an x squared over 2 from -3 to 2. So first we substitute the 2 in here, which we can see we've done here, and here we substituted in the 3. Cleaning it up and combining like terms, well, adding the contents together and subtracting, we get about 20.83 units in between those two functions. Let's see what we have coming up next here. All right, let's have you guys set this one up all on your own and solve it, and then we'll check it together. So please pause that video, and then we'll look at it together. So you probably noticed when you set this one up that our g of x function has higher y values than our f of x function. So we actually put it first and have the 2x subtracting then the x squared minus x and integrating that from 0 to 3. You can clean this up because 2x minus a -x gives me 3x minus x squared, makes the calculation simpler. When we integrate 3x, we get 3x squared over 2. When we integrate x squared, we get x cubed over 3 from 0 to 3. Plugging it in, we'll find that our second parentheses equals 0 because when you substituted 0 into both of these terms, we got 0. And our final answer is 4.5 units squared. So I hope this has all made sense. In our next video, we're going to look at the Gini index and applications of the area between two curves. Thanks for watching.